So in our last section of this video, we made a smart contract, a hold to claim airdrop smart contract. So in this video, we're going to be testing our smart contract using Foundry. So we're going to be writing some unit tests for our smart contract to test the functionality of our contract. So first things first, we need to create a directory to house our Foundry project. So we are going to do mkdl. We're going to do a test airdrop. So then we're going to do cd our project. We enter our project test airdrop. Then we'll do a code period to enter our project. So it's going to open a new window. So we're going to get rid of the old window. So enlarge this. Then we'll initiate a new Foundry project. So we'll do a forge. Alright, get rid of this. So wait for it to pop up. So we'll do a forge init. So after running forge init, you can see our basic Foundry setup. You can see the lib, the script, the source. Source is going to be containing our smart contract. Test is going to be containing our test files. So we're going to delete the counter. It comes with a default counter app. So delete counter, then we delete the test file for the counter. So after we delete them, then we'll get our smart contract. So here we're going to create a new smart contract called airdrop dot sol. So then we'll create another one, hold token dot so. Then we'll create the last one, reward token dot sol. So we're going to be pasting each and every token. So we are going to our remix. So grab our whole token. Now paste it here, whole token. Now go to our reward. Sorry, that was for reward. And save. Then hold. Let me get rid of this. Then this is for our hold token. Okay, so we're going to paste it here. Our hold token, then we're going to copy our airdrop app. So we're going to paste it here. Airdrop apps. So I didn't really copy anything. So paste it here. So we need to install this OpenZipilion dependency. So we need to access our OpenZipilion, the GitHub of OpenZipilion, then access our ERC20 smart contract. So in order for us to do this, you can see it's already showing a red mark. For us to do this, we need to do a forge install OpenZipilion. I'll be dropping this link in my description so you don't need to worry about anything. So a forge install. Okay. Let's do target directory is part of our own. Okay. So we're going to do let's do a git add period. So I'm going to do a git commit then correct anything here. Okay. So let's try installing our opposite billion contract. Let's see if it's going to work. So we're going to do just one. Hopefully it works this time around. Okay, I think it's working. Fingers crossed. Hope it works. Think we'll be done in no time. So just hold on a bit. Done in no time. Okay, it failed. So I think I'm going to run this command. Then so we're trying to debug this sub module exited with code. So I think I made a video about that. So you can go check it out. Can use it to solve those kind of errors. Those kind of errors, something related to GitHub. I don't really have an idea, but I know it's related to GitHub. So I hope this runs. So we actually had two errors, the first error and the second error. So the first error, we tried to solve it, it didn't work. So we're trying to use the second way to solve the other error. Let's see. The same error, by the way. So, okay, I think it worked. Okay. Fingers crossed. Okay. Okay, we've installed opposite plan, so we've installed it. So we're able to solve that gate module using my video. You can see this was the code we used in solving it. So let's see if we got it. So you can see we got the opposite billion contract. You can see contract, then you can see token, then you can see ERC20. So you can see ERC20.so. So we access the ERC20.so. So go back. They will do something in our Foundry .tmol. We are going to do a remapping. I'm going to do remapping. Mappings equals to, let's read this. Then in our place we copied our installation, we're just going to add this. So we're going to copy our mappings. Then we're going to add it in our mappings folder. So I think that's all for that for mapping. I think that's all for that. So we'll go to our test folder. Everything has been set up. So we'll go to our test folder. We'll create a test called airdrop test dot sol. So I'm going to do a spdx. This will be license identifier. So thanks to Auto Copilot, it's completing my statement for me. Pragma Solidity 0 greater than 0.8.18. So we'll do a contract. Airdrop test is test. Right? So we need to import our test script. So we import do bracket test from forge std slash test dot sol. We do another import. We're importing our contract. Import airdrop from dash do slc dash airdrop dot sol. Then say we do for our hold token import hold. So hold token from dash slc dash hold token. Then next one is our reward import. Cool. Reward token. No, it's supposed to be in capital letter. Reward token from dash source reward token. So I think we're done with that. So we're going to be creating an instance. So we'll do airdrop. So we want to store after deploying the contract, I want to store the variable, the address in this variable. There we do hold. So our first function in our test file is always going to be our setup. So it's going to be a public function. So we're going to be deploying hold and reward first. So we're going to do hold token equals to new hold token. So we're going to do the same for reward. Reward token equals to new reward token. Then airdrop is equals to new airdrop. So it's going to be taken in. Our airdrop contract has constructor. The constructor takes in two value. So constructor takes in two value, which is the hold token and the reward token. So we're going to do a hold token, then a reward token. After doing that, we are going to transfer we always transfer what token dot transfer. We're transferring to our airdrop contract. We're transferring 1 million token multiplied by 1 raised to power 18. That's 18 decimal. So I'm going to do a forge test right now to see what we got. So forge test. Let's do a VVV. So declaration reward token. Reward token. Okay. Okay, contract's name is actually RWD. So let's just change the contract name to reward token. Let me just reward token. So we do a forge test the VVV. So fingers crossed, hope our test pass. What? So okay, so oh my goodness. We actually forgot to convert all these type to address type. Address. So converting this to an address type. Same with this. So convert this to an address type. Okay, I think we're done with the new airdrop. Also convert this to address because we are going to be passing in. So if you understand what we did, so the airdrop constructor needs to address. So we are converting this contract instance to an address. Also this contract instance we are converting to an address. So let's run the forge test this time around. Hope we get it right this time around. Okay, no test to run. So we're going to do a forge test. I think our setup was okay. So we are going to look for a test. So we are going to check the claim fee. So we're going to do a function test. We're going to check claim fee. It's going to be public. And then we're going to do airdrop dot as a claim fee. We're going to do a uint 256 to a fee. So we're going to do assets dot assert equal, we're going to do fee should be equal to fee should be equal to 5. I think it's 0. Sorry, let me 0.05 should be equal to 0.005. Can we do an iter here? Fudge test v. So the fee should be equals to 0.005 iter. Okay, our test passed one pass successfully. So you can see our test passed. So yeah, our test passed successfully. So you can see more information about the test. So claim, you can see returned 5, returned this amount, 5 is to power 15. So the test ran successfully. So what other tests are we going to do? So we're going to do we're going to check the claim amount. So we're going to check the claim amount. So we're going to do a function test claim check claim amount. So it's going to be a public function. So we're going to do a unit 256 amount. So we're going to do airdrop dot claim amount. So we're going to do assert physical amount must be equal to 2000 token multiplied by 1 raised to power 18. So 10 raised to power 18. So we're going to run fudge test. So it's supposed to be 2 tests passing. Now what is wrong? The test failed. So I think it was supposed to be 1 raised to power 18. Right? So I think it was fudge test. Yeah. I think it's supposed to be 1 raised to power 18. So it's going to give us 18 zeros. Okay, 2 tests passed. Okay, passed. So in our next section of the video, in order not to make this video too bulky, in the next section of the video, we are going to be doing more tests.